Welcome to our deep dive. Today we're tackling machine learning. For those of you out there who are fascinated by algorithms, I mean, how do they actually learn from experience? Well, we've got some seriously cool sources to help us unpack that.
It really is a fascinating area. What's so intriguing is that machine learning, it didn't just sort of appear out of nowhere. It actually grew out of this pursuit of artificial intelligence.
Right, AI. Right.
Exactly. AI aims to create, machines that mimic human intelligence. But machine learning, well, it's more focused on solving practical problems, with algorithms that get better the more they learn.
So like a more practical, hands-on cousin of AI getting things done.
That's a great way to put it. And the thing is, it's already everywhere, even if we don't always realize it. I mean, think about it. Those Netflix recommendations, the ones we love to hate, or even helping doctors diagnose diseases. Machine learning is kind of quietly revolutionizing things, all around us.
Yeah, it's kind of wild how it's woven into everything. But before we get ahead of ourselves, I'm curious about the roots of machine learning. Where did this all begin?
Well, the actual term machine learning, it was coined way back in 1959 by Arthur Samuel. He was a real trailblazer, in computer gaming and AI.
Wow, 1959. That's earlier than I would guessed.
Right. But what's even more interesting, I think, is that this desire to study, human cognition, that's really the foundation of machine learning. That goes back even further. Like in the 1940s, Donald Hebb, he had this model of how neurons interact, and it actually inspired some of the early work on neural networks.
So they were basically trying to reverse engineer the human brain right from the start.
Kind of, yeah. They were fascinated by how the brain learns, and they wanted to replicate that in machines. There's even this story about an experimental learning machine from the 1960s called Cybertron.
Okay, I got to hear. Tell me about Cybertron.
Well, Cybertron, it used something called reinforcement learning, which we'll get into later. But get this, it had a goof button.
A goof button. What was that for?
Well, a goof button let the human operator correct Cybertron's mistakes, while it was learning. It's just a funny little detail, but it really shows you how hands-on those early experiments were. I mean, imagine a real undo button for a machine's learning process.
That's a great visual, like a very literal trial and error kind of thing.
Exactly. Then you fast forward a few decades and you get to Tom Mitchell's work in 1997. He offered a more formal definition of machine learning that's still widely used today. It shifted the focus, you see, from perfectly mimicking human cognition to, well, just algorithms that can improve their performance based on experience.
A more practical, results-oriented way of looking at it. Makes sense. So how do these algorithms actually learn? What are the different approaches they take?
Well, that's the heart of it. There are three main types of machine learning. We have supervised learning, unsupervised learning, and then reinforcement learning.
Okay, those sound intriguing. Let's start with supervised learning. What's the basic idea there?
Okay, so imagine you're teaching a kid, right, to identify different fruits. You show them an apple and say apple, then a banana, an orange, and so on. And the child, they start connecting the look of the fruit with the name.
So you're giving the algorithm the input, like the image of the fruit, and also the output, the name.
Exactly. It learns from these labeled examples and builds a model that can then, identify new unseen fruits. Think of those spam filters, in your email. They learn to tell spam from real emails based on previously labeled examples.
That makes sense. So that unsupervised learning, is that where the algorithm just has to figure stuff out on its own without any guidance?
In a way, yes. In unsupervised learning, you don't give the algorithm any labeled examples. It just gets a data set and has to find patterns or structure in that data. Imagine giving someone a big pile of puzzle pieces, all mixed up, and asking them to sort them into groups based on how similar they look.
So the algorithm has to find those hidden relationships, all on its own, with no instructions.
Precisely. A common example is customer segmentation, grouping customers together based only on their buying history, without knowing anything else about them. And the algorithm, it might discover clusters of customers with similar buying habits, which is obviously valuable for marketing.
That's super clever. So we've got supervised learning with the labeled examples, unsupervised learning where it's kind of on its own. What about reinforcement learning then?
Now, this is where things get really interesting. Reinforcement learning is all about learning by interacting with an environment. The algorithm, it takes actions and then gets rewards for good decisions, and penalties for bad ones, kind of like training a dog, right?
Yeah.
You give a treat for obeying a command and maybe a little no for misbehaving.
So the algorithm is learning by trial and error, trying to get those rewards.
Yeah, that's the basic idea. A great example is self-driving cars navigating a city. The algorithm gets rewarded for, driving safely, reaching the destination, but gets penalized for collisions or traffic violations.
That's a really powerful concept, especially with self-driving cars becoming more and more common. So we've got these three main approaches, but it sounds like there are even more, specialized types of machine learning too.
Absolutely. We touched briefly on dimensionality reduction, which simplifies data but keeps the key information. It's like taking a complex 3D image and creating a 2D version that still has the important detail.
Okay, that's a helpful way to think about it. You also mentioned self-learning and sparse dictionary learning. Those sound interesting. What are those?
So self-learning, that's fascinating because the algorithm, it actually generates its own feedback signals, so it's kind of learning from itself. And then sparse dictionary learning, that's about representing data using a limited set of building blocks, which can make, analysis and processing more efficient.
It's starting to sound like there's a whole toolbox of machine learning approaches, for different situations.
That's a great way to put it. Choosing the right approach really depends on the specific problem and the data you have. There's no, one-size-fits-all in machine learning.
It's starting to feel, I don't know, less like magic and more like a strategic science, which is really cool. So now that we kind of get the different approaches, I'm really curious about the models, that actually do all this learning. What are some of the key players in the machine learning model world?
Well, we've already talked a bit about neural networks, right? Those systems that are like modeled after the human brain.
Right, those networks of artificial neurons, yeah.
Exactly. And deep learning, that's a specialized area within that.
Right, using multiple layers.
Precisely. Deep learning uses multiple layers of these artificial neurons so the model can learn these increasingly complex representations of the data.
Wow, so it's understanding the data on like a deeper and deeper level.
That's a great way to think about it. And then another common model is the decision tree.
Okay.
You can picture it like a flow chart, right? Where each decision kind of branches off into a different path and eventually you get to a conclusion.
I like that, like a flow chart.
Yeah, that's essentially how a decision tree works.
Okay.
It uses a series of observations or like if-then-else statements to get to a prediction or classification.
So like a decision tree can be used to predict if a customer is going to buy a product or not based on their browsing history and stuff.
Exactly. Each decision point would consider a specific feature like age or the product category and then lead to a final prediction.
Okay, I'm starting to see how these models can be used in so many different ways.
Yeah, it's like having a specialized tool for each task.
Right.
Another powerful one is the support vector machine.
Okay.
That's a classifier that tries to find the best boundary, to separate data points into categories.
Okay.
It's like, imagine you're drawing a line to separate apples from oranges on a graph, right? Well, a support vector machine, it would try to find the line that maximizes the separation between those two categories.
So it makes the division between the categories as clear as possible.
Exactly. And then there's regression analysis,
Okay.
which is a statistical method. It's used a lot, and it's all about understanding the relationships between variables.
Okay.
So you could use regression to, for example, predict someone's height based on their age and genetics.
So unlike those other models that categorize data, regression is about predicting a specific outcome.
Exactly. You got it. And then, of course, there are more specialized models like Bayesian networks, Gaussian processes, and genetic algorithms, each with, their own strengths and suited for certain problems.
Wow, it's incredible how many different machine learning models there are out there.
It really is. It's like a huge toolkit with a specialized instrument for every job you can imagine.
Yeah, it's amazing. But even with all these cool tools, the success of any machine learning project really comes down to, the data.
Oh, absolutely. Like they say, garbage in, garbage out.
Right, exactly.
Yeah.
Speaking of success, I'm curious about like real world examples of where machine learning has, actually made a difference.
Well, one famous example is the Netflix prize competition back in 2006.
Oh, yeah. That was the challenge to improve their movie recommendation algorithm, right?
That's the one. Netflix offered a $1 million prize to anyone who could improve the accuracy of their existing algorithm by at least 10%.
Wow, $1 million.
It is a big deal.
It really sparked a lot of interest, yeah.
It really did. It was a huge wave of research and innovation in the field.
So did anyone win? What happened?
A team of researchers, they won the prize in 2009.
Okay.
They used what's called an ensemble model, which basically combines the predictions from multiple models to get better accuracy.
Oh, that's clever. But didn't Netflix end up not even using that winning algorithm?
That's right. They actually found that user ratings weren't the best way to figure out what people actually enjoyed watching.
Oh, interesting.
Viewing patterns, like what people actually watch and for how long, turned out to be way more valuable.
That makes sense.
It just goes to show, even the most successful models, they can be challenged by real-world scenarios.
So it's not just about being statistically accurate, but also understanding the context and using the right data.
Absolutely. That's a crucial point.
So what are some other, cool examples then?
Well, there's this fascinating example from the field of art history.
Art history. Wow, okay.
Yeah, researchers used machine learning to analyze a ton of paintings.
Okay.
And the algorithm, it actually found these previously unnoticed influences between different artists.
Wow, really?
Yeah, it revealed these hidden connections and stylistic trends that human art historians had missed.
So the algorithm, it's like it has this unique perspective, seeing patterns that we don't even notice.
Exactly. It shows the power of machine learning to find new insights and perspectives.
I love that.
And we're really just, scratching the surface here.
Right.
Machine learning is revolutionizing finance, medicine, so many other fields.
It's incredible how much potential it has.
It even played a role in predicting the 2008 financial crisis.
Wow.
It really does seem boundless, but it's also important to remember that, it's not a perfect solution for every problem.
Right, it has its limits.
Of course, like any tool,
Yeah,
we need to be aware of those limits and use it responsibly.
absolutely. It's all about understanding both the strengths and the limitations of this powerful technology. Wow, this has been, I don't know, a really eye-opening deep dive into machine learning.
It's a field that it never gets old. There's always something new.
I can imagine. We've covered so much from the history of it all and how these algorithms learn to, the actual real-world applications that are already changing things up.
And the thing is, this is really just the start.
Right. It's constantly evolving, new algorithms popping up, new applications all the time. It's moving so fast.
Yeah, it really does feel like we're on the edge of something huge.
It's exciting, but also a little bit, I don't know, intimidating, maybe. So where do we go from here? What about our listener who's, just starting to learn about all of this?
Well, the Wikipedia article, the one we've been using, it actually mentions some journals and conferences that are all about machine learning.
So if you want to keep up with, the latest and greatest, that's the place to be.
Definitely. Those publications are great for staying on top of the research and the newest developments.
And I'm sure there are, a ton of online courses and resources, too, for people who really want to get into the nitty-gritty, the technical stuff.
Oh, yeah, tons. There's a wealth of information out there if you want to learn more.
It's all about staying curious, right? Never stop exploring.
Couldn't agree more. I really hope this deep dive has inspired our listeners to learn even more about machine learning, to really dive in.
Me too. As we wrap up here, I want to leave you with something to think about. Machine learning, it has this incredible potential, right? It can solve these really complex problems, even create entirely new industries.
It's a force to be reckoned with, that's for sure.
But ultimately, its impact, it depends on us, on the choices we make.
The choices about how we develop it, how we use it, how we govern it.
Yeah, it's a future that we'll all be shaping together, one algorithm at a time.
Thanks for joining us on this deep dive into the world of machine learning.
We hope you enjoy the journey and that it's, sparked your curiosity to learn even more. Until next time, keep exploring and keep asking questions.